right, so we're going to do section 1.3, frequency, frequency tables, and levels of measurements. So the first thing is it's supposed to remind you that you only round your answer at the very end. So only round off your answer at the final answer. We're going to talk about levels of measurement. So a level of measurement has to do with the different scales that data can fit into. There are 4 of them: nominal, ordinal, interval, and ratio. Okay, so these ones I can guarantee Snow is going to ask you about. Okay, nominal is qualitative, so it's categories, and it's categories that you cannot put in order. So if you're talking about cell phone companies, we can give them all a name, but we can't say which one is better than the next one. All right. Ordinal is very similar, but it can be put in order. So something like if you're taking a survey and it says that you strongly agree with, disagree with, or strongly disagree with, we can put those in order, but they're still categories. Okay, so nominal and ordinal are very similar. This one can't be put in order, so nominal does not have order. Ordinal does have order. And then we have interval and ratio. An interval scale means that you have differences between the data points, and that differences has meaning. And it does not have a starting point. This is important right here. Does not have a starting point. Okay. The ratio scale has a starting point. It has a 0 point. The difference in the data points still has meaning, and you can put it in order, but this one has a 0 starting point. Interval and ratio are very similar in that the differences have meaning between their data points, but on this one, this would be like taking your temperature and looking at temperature in Fahrenheit or Celsius. You can have negative temperature, so 0 is not the beginning. But if you look at the ratio, you might have something called kelvins. So if you measure temperature in kelvins, kelvins has an absolute 0 starting point. Okay, moving on from levels of measurement, let's talk about frequency. So we have 20 data points. So we have our different data points listed, 2, 3, 4, 5, 6, and 7. But then we have their frequencies, how often they occur. So I have 1, 2, 3 2s. So the data value of 2 occurs 3 times. So that's just what frequency is. It's how frequently that data value occurs. Relative frequency is when we write it as a ratio or a fraction or a proportion. In other words, when we write it in compared to the total number of data values. So when we look on top of page 29, we have that same data value, that frequency, but now we've added the relative frequency column. So this is when we say, yeah, we had the data value of 2, it occurred 3 times, but now we're comparing it to the total number of data values. And so it's 3 out of the 20, or 0.15. And you can think of this also as a percent. So it can be written as a ratio or a fraction, as a decimal, or as a percent. But the relative frequency just allows you to compare that data value frequency to the total number of data values. Cumulative relative frequency means that we're going to take these frequencies and we're going to keep a running total and keep adding that next one down. So we still have this first one, our data value of 2, frequency 3, our relative frequency as 3/20ths or 0.15. And so because this is our starting point, that's where our cumulative relative frequency is at. So then we go to our next one. We have the data value of 3. It happened 5 times. That's 5 out of the 20. But now we're going to take that relative frequency and add it to what was above. So now we have a running total. So this row plus this row, so our running total cumulative frequency is 0.4. That means that we've got 40% of our data contained within the data points of 2 and 3. So this is just a running total. Using these frequency tables allows us to answer a lot of different questions fairly quickly. So if we look at table 1.13, we have inches of rainfall, and it's broken not into data points, just into categories from 2.95 inches to 4 and all the way up through 15.07. We have our frequency, how often that data point occurs, or a data point falls within that range, and then our relative frequency, and then our cumulative frequency. The relative frequency should add up to 1 because we should have if we combine all of these, we have all 50 data points out of the 50 sampled. And then this should also add up to be 1. Okay? Otherwise, we're not getting 100. We're not counting 100% of our data points. So that's a quick check to see if you have any issues with your frequency tables. So if we take a look at the question that it's asked on this one, find the percentage of rainfall that is less than 9.01 inches. So the percentage of rainfall that is less than 9.01 inches, that means this is our endpoint here. It's this and everything above. Well, we've already got that calculated here in the cumulative relative frequency because that includes all 3 of these, which is 0.56. We could also look at the percentage of rainfall that is between 0.699, so between 0.699 and 13.5 inches. And that's these 3 rows. So instead of using my cumulative frequency, this one's going to be faster just to do 0.3 plus 0.16 plus 0.18. And that will tell me the percentage of cities or towns that had rainfall between 0.699 inches and 13.05 inches of rainfall.